好听。地球门口应该有，地球门口有一个，我背后有个人在追我。我跟你说，去了几杆，然后回来跑图就能跑几关。以前我记得矿场没啥人去。好，全体掉血。好，你这是去找车，这就是你找车的态度吗？看一下还有啥？好家伙，有人！我操！走了走了走了！去旁边，再往前开，再往前开，往前开，往前。果然转移都转移不过人家。这个，我觉得等会儿他们要过来，也会过来。捡点东西。可以啊，一个。来了，他们绝对会过来的。你别干嘛？干啥呀？对，我去吃饭桶。我去下一把。 从刚才他们扫我们车的那个技术来看，他们估计跟我们差不多，速度比我们还要快。然后理解。掉圈肯定是有人，这你才怀疑。
Okay, am I audible?
Yes, yes. I can hear you. Can you hear me?
Yeah. Okay, fine. Okay, first of all, I would like to share the screen. Okay, for one thing.
I guess you can share a screen.
Yeah, I can share your screen, share my screen. So, can you see my screen now?
Wait a second. Is it just you are good?
Hello.
Yeah. Now it's okay.
Oh, okay, fine. Actually, I'm going to show a few things what you mentioned in the last meeting, but it did not go on.
Yeah,
Okay.
it's okay.
Mm-hmm. Not store Igneous project. The issue with the laptop is still prevailing.
Yes, it is a little.
I have to sort it out before my presentation on, I think, 30th December, I think. Most likely. Yeah. Okay. So first I am coming to the graphs actually. Okay. 20 second back. Oh shit. Okay, fine. I will open the presentation. It will be better because otherwise I have to open the MATLAB again.
Okay,
Fine.
you can open.
Okay. Weekly presentation.
Attention.
And then 24th weekly presentation. Okay. Can you see my screen now?
Yes, we can see your screen.
And the PPT is open, right?
2007.
The PowerPoint is opening. Okay, fine. Okay. I'm going to straight going to the graphs. Okay. First, I'm coming to. I think I can skip this one because this is a little bit error, so I think I can skip this. Okay, fine. Here.
Maybe you can start with the last slide.
Yes.
You draw by MATLAB. The last slide. I mean.
Sorry, I cannot.
I open my PowerPoint. Wait a second.
Okay. I mean, can you see the screen?
Yes, we can see your screen.
Fine. Then, yes, here in the topmost graph, this is niobium versus ytterbium. Simple. I actually made the graph based upon the filtered data on geodag data, especially not the Chapman data set. I think it would have been much better if we could do in respect to Chapman itself.
I have a question. How many data you use for the ND
Sorry?
and Y? Hello, can you hear me?
Hello. Yeah.
Hello.
Yeah. Hello.
I have a question about how many data you used for this diagram.
Okay. I think it was more than 4,000. I think.
4,000. Oh, okay.
Now 4,000 is not sufficient for our data. I have made just a preliminary data. I mean preliminary graphs, and we need to incorporate all the say 15,000 or 16,000 data sets of Chapman and Xerox combined to get the thing for our works. So what I was talking about in the previous presentation, in fact, that we need to check carefully these data, because the data outliers which will uh, omit by using the SVM approach.
Yeah.
Hello.
Yes. We need to combine the Chapman data and
Yeah.
this data, the Xerox data. But first we need to make sure that all the data we combine is the correct one, and I think there will be some different order of the
Yeah.
some different
Uh,
order, and some such as in the in the Chapman's data I see the MG value, but in Xerox data I don't pay much attention, but I didn't saw the MG value.
Yeah. So first
So
of all, yeah, that is the thing that we need to combine. I just made a preliminary graph based on our check database, and also there are many things like I have written that it is not sorted based on the age. If we sort it out in terms of say location or age, something like that, it would yield some different but interesting results, etc.
uh,
Something like that.
I have a suggestion. Maybe not suggestion, because you draw the figure in the nice, but it look like a mess.
Yeah.
Maybe you can show it in the point and
Yeah,
draw
exactly.
a trend.
Because yeah, exactly, because it looked like a mess, and in fact, after combining all the data, we just need the change line only. I mean, here we are getting all the lines, like for a particular location, this line. Say, for example, can you see my cursor? Cursor?
Yes, I can
Yeah,
see it.
they say for example, particular location we are getting say this line, another location this line, another location this line. Like it's really a mess. So first we need to consider the SVM to sort out the data, or we can just sort out on based on our locations or age correlationships, and then we can get the change line and some other things. And I think it would look like less messy, I think.
You think
Then
it is caused by the location and the age?
it might have been different aspects. Like for example, you see this line,
Yeah.
right?
Yes.
This is a kind of absurd line. For example, like niobium and ytterbium with the when the ytterbium when the yttrium concentration is zero, niobium cannot be zero again. Both should start from near zero values necessarily. So this might be due to some different effects, like for example, the mineral that contains the niobium, or for example, there had been a decoupling kind of thing, or so much example. So we cannot sort it out whether this is so. That's the point, and conforming to your points as well, that we need to
Yes.
sort it out.
Can you? I mean, it can be caused by the wrong recorded in our Excel, and maybe you can check the data in
Record.
the original paper. It is in original paper, it is the data like this or just the wrong record in our Excel file?
Oh, you mean the datas have to be recorded in a Excel file, right?
You just show some you say it is maybe a wrong. From my understanding, you should it is maybe a wrong data because for a high NB value, but very low Y value. So sorry, I'm not familiar with the name of the elements because so I just
Yeah,
called
yeah,
them
yeah.
NB or Y. Uh, uh, so it may be caused by the wrong record of the data because from my work experience, have some misrecorded in the geologic data from the original paper to their record to the database. For geologic, maybe you can check it.
Yeah, yeah. And also one more thing is uh, in some georock data I am seeing, for example, the outlier data is falling far behind or far beyond the limit of any kind of graph. So, and I am back chasing it with the paper, and I am seeing that the mineral is itself something else. Like, for example, I am getting very high concentration of strontium versus niobium versus some other minerals, and I am getting very high concentration of SR, for example. And SR is very much compatible in plagioclase. So while backtracing it, we are getting that due to plagioclase, this is happening. But hello, am I still audible?
Oh,
Am I still audible or not?
uh, uh, it may be caused by some mineral
Mineral or something else, like alterations or whatever. It can be anything, for example.
yes, but we need to make the data in our files the same with the original data. If the original data like this, we just keep it in our data, but at last we can drop it for our analysis.
Exactly.
Yeah.
The same thing is done by the Garnet group. What I am
Sorry,
seeing now.
sorry.
Hello.
Your screen is not shared now.
Oh, I just got up the internet. Wait a minute. Screen. Now it's visible, I think.
Yes, now it's visible.
Wait a minute, please. Yeah, fine. And in the Garnet group, what I have seen that they have sorted out the total oxides surpassing 101 or 102, I think, something like that. And based on that, they are retracing it with the paper and just omitting the data and some and stuffs like that. So I think it is better for us as well to retrace it to the paper, recheck, and then just omit it if it's kind of alteration, or for example, it is the mineral phase with different compatibility, etc.
Okay, okay. I have a question. What the TAS means? And
TS, okay, okay. TS means the total alkali versus silica. Total alkali means the summation of the oxides of sodium and potassium.
and potential.
And this actually falls in the TS diagram by Harkar, I think. There is a kind of classification based on which the rock names are given, and also the evolution of the rocks are described.
Okay, okay. Maybe you can type it in the chat. In the
Okay, fine.
chat.
I will just show you the actual diagram or the original classification where you can just quantify it on your own. That is gone. Achha. Second second important point is for this diagram. I think you are familiar with radiometric dating. I think.
Yeah, yes.
Yes.
I do a lot of the network. Sorry, the uranium net isotope dating for local.
Yeah. So for this diagram, I think you can make out this is kind of a Concordia Discordia curve, like the uranium versus lead. Here you will see that actually the graph should see the graph is kind of curved here. Can you see my cursor?
Yes.
Yes. You see that graph is kind of curved here, and it has approximated a straight line.
Yes.
Similarly, for this part, there is also another curve, etc. So this is a perfect example for the Concordia edge correlationships, or for the straight lines. These are Discordia, which I was looking into some papers which corresponds to loss of either lead or uranium or something else. Mostly the magma mixing. So I have a question here. Can we discuss with Professor Liu how about the composition of the melt or the fluid generated from the igneous, from the Indian plate? Can we get an estimate from this type of graphs or something else? It is just my fundamental question.
Maybe maybe we can discuss it.
Yeah.
Yeah, but
It's a question to be discussed. Okay. Tell.
the for the ages for the age in for the Igneous rock in the Tibet area, from my knowing it, the Igneous rocks have we can say the Igneous from the Cretaceous to the about
Miocene maybe.
2 million years ago.
Yeah.
Yeah,
Well,
it is about 100 million years igneous events happening in the Tibet area.
exactly. And from this Concordia curve alone, we can get an estimate of the exact age of some events. Like for example, we are getting a loss of uranium after some event. So then there might be a kind of fluid activity which has expelled all the uraniums out of the system, etc. Like similarly, we can. I think from the Concordia curve we can get an age constraint, like a narrow age range for our events. I think.
Yes, it's maybe.
Maybe. Yeah. And another question I think to be noted is in our projects also we have naturally the major oxides summation of, let's say, 101 or 102 or sometimes surpassing in fact 101, 102 values. So how to deal with them? That is also another question.
I also have no idea of it.
Yeah, because actually I borrowed this idea from the Garnet group. The Garnet group is simply omitting the 102 plus datas. They're just omitting. But I had many questions, many doubts. Like for example, if we have total oxide data of 101 or 101.5, on which basis what should I omit the data or not? Or in fact, there might be also some charge imbalances in the rocks, which can give us a good idea about the error in the oxidation state, in fact, of the iron or for the manganese, say. So I am not sure about this omitting kind of data. So could you please ask this to Professor Liu? It would be much better.
Yes, we can discuss it with at the weekend. But I I maybe I can't remember much of your problem because for me to to enter the information in English is still a little bit harder. Could you write down a
Yeah.
Word
I will just frame the
file?
questions. Yes. I
Yes,
will just frame the questions.
and
I think I can send it directly by Slack.
yes, you can you can write a file and then send us like your file in and then I will arrange all the questions and for the discuss with the Professor New.
Fine. That is very nice. Fine. I have stopped sharing, I think.
Yeah, you are stopping
Okay,
the
fine. Okay, so that's all for me to discuss or to decide whether to keep some data or not.
Okay, but I remember, and as last time you said you want to study the uh, let's have a look. Sorry, you said you want to study the effect of the water and some volatile
Yeah,
fluids.
about that. Yes.
Yeah,
I, I
I
just forgot it. Yes.
yeah,
I have to share the screen again, I think.
okay.
Fine.
I'm not clearly how it directly
Hmm.
influence the rocks and
Yeah. How do I share the screen again?
you can just share a screen.
Yes, but uh, I'm trying to share. Okay. Fine. I got it. Yeah, you can see it now. Fine.
Wait a second. Now it's okay.
Okay. Okay, I'm opening the thing. It has already opened. Fine. I have uploaded, I think, 3 or 4 papers on in Nut Store. That is the reading materials section. Here, just for an introduction, I would like to say that this paper, this MV outliers, you can see it right here.
Yes. I see it now.
This, yes, this and the UTF this paper, this and this paper, this might be required for our outlier data checking during the SVM. I just added the papers. Okay. Apart from that, I'm going to see. I was just going through a old paper, fluid chemistry, by I think Bernard, maybe. You can check it out on your own because I have uploaded it in the Igneous project reading
Yes,
materials.
I have seen it. The chemistry of the subduction zone fluids.
Yeah. Here, just this paper by Manning, Craigie Manning.
Yeah.
This acts as our guide to get the compositions, like for example H2 and the other fluids what I was talking about. Now here
It
in
looks
this,
like a
yeah,
geodynamics modeling of the fluids.
yes, kind of. Now here I just went through this recent paper, this subduction fluid element modeling, what I was exactly trying to mention. Here, yeah, in this paper, you will see that they tried to model exactly the compositions of the subducted fluids or the fluids that are released from the plate, subducted plates. And you can go through it by the processes or some other things. You will find it interesting. And I think what I was talking about, that based on these kinds of models, we can model the trace elements, in fact, in our cases. And if we can model the trace elements, we can get the direct behavior of the type of fluid, like whether this is watery or carbonaceous or something else.
Uh,
You can go through it if it is viable. You can go through it.
okay, I will
Yeah,
look at it. It all uses the trace elements.
trace elements. And similarly, by this paper, subduction melting by dehydration, this is a very good paper, though kind of a little bit of geodynamical, but still it's contains geochemical modeling. Here they have mentioned how to identify the different types of fluids, and based upon that, similarly, they have modeled the concentrations and some other stuffs. I think we should focus more on this, I mean, modeling the elements of the subduction fluids. So I think this can be discussed again after you go through it once.
Okay.
Okay.
Maybe I guess Professor Liu also haven't read those papers.
Yeah. If he has the paper, I was actually looking for his paper, but I could not get it. If you can access those papers, please share it in our groups. We have to gather as much as possible. Okay. You can see it later, I think.
Yes, I'm just reading the abstract of those papers.
Okay then.
Okay, I will maybe I will read those papers later. Because it has several papers. Maybe need some
Hmm.
time for reading it.
Yeah. Exactly. It's
Yeah.
okay, fine. And for the time being, I am eagerly waiting for the English translations of the SVM videos what Professor Zhang had shared in the group.
Uh, I guess they are now making more videos in Chinese for because they have all made before uh in uh before we they write all the codes in uh in a in a software called Jupyter Notebook. It is needed to run the codes one by one, and now they are making them in py point py files. It means we can run this run the codes like the SVM in just one click, or just one, and we can just click the enter. So they have made some changes for the codes, and they just introduce the new changes in some Chinese videos. But for the English videos, uh, they haven't prepared. So I guess we need to wait several weeks, and then we can get some uh, video uh, videos in English to explain the codes. For them, it's also a hard work to explain the codes in English because we all learn it in Chinese, so it's need some time for them to do it.
Yeah, there's a point. Okay, it's fine. I am trying to learn on my own
Uh,
the codes.
I have a question for the SVM. Have you run it well, or just a success run?
I just run your codes, what you have shown in one meeting
Yeah.
in a few weeks back. I just run those codes, and the results are exactly similar because what you have shown, the results will be similar. I did not do much after that.
You means you can run it well. The haven't occur some errors.
Yes.
Okay. That's good. That's pretty good. And maybe
Hmm.
you can run it in.
Yeah, I am trying to run it on my. I mean, some using some other codes also, and also I would like to share one thing that a few days back I was checking internet for this kind of data effective data filtering. I have seen that there is a code for even data filtering itself. Like in SVM, there is a problem when the data are not there, it just omits the whole field, right?
Yeah.
There is a problem with SVM. And here, by using the code, what I have seen, I just lost it and I will try to find it again, whatever. By using that code, we can just identify the NaN, that is the not a number values before we begin our codes. That
Um.
was a lot of
Uh,
convenience.
Actually, I have no idea what the algorithm you are talking about. Maybe you can share it.
Yeah, I will try to share it through Slack maybe. Okay, I will just share the link. Uh,
Okay.
Hello.
Hello, you just get disconnected.
Yeah. This is my internet now.
Uh,
Whatever. What I was talking about. Yes, and another thing is this is just regarding our data checking process. Uh, Orko Shahu has left our group in the middle of his work. I think you are aware of that. So he just checked a few of his data from the GeoRock. And similarly, we are having a trouble with the paper database access. So if you can kindly access those papers and send it via maybe Slack or something. Whatever. Thank you. That
yes,
is
but you need to make a list of what some paper
hot
you
papers.
can't find.
Yeah. I will send the paper to you.
Yeah, you can make a list in Excel files, and I will check it one by one.
Exactly.
I have made this.
Hello, sorry, what?
I have made the list. In the Nut store, you can find it.
I don't know. I don't understand what you are mean. You get
Oh,
dismissed.
she said that she had made the list of the papers and she had uploaded in Nut Store.
Oh, okay. Yeah. Okay. But I don't know which the list.
Yeah,
Maybe you
we'll
can
make a video.
maybe you can just use a screenshot and send it in the snack, so I can find it and will check those papers.
Fine. Fair enough.
The I also have a question for your work in the arrangement of the geographic data, and as we talked maybe 2 weeks ago, the I mean the four Excel files, and how is it, because uh I wanted to talk it with Professor Liu this weekend for uh, uh the current situation of the geologic data. So
Yes.
I mean the that's four Excel files, maybe we are a good way to show the Professor Liu the situation
Okay.
of the data.
I have made the file for the filtered data. I will make the other tools by tonight or by tomorrow, and we just copy paste the data in those files. That is okay.
Yes, thank you. Mm,
Yeah, it will be. Yes. We need to present the data in a well manner way. Yeah.
yeah, and uh, for and data, Amanda. I, I I also have a request for you. Uh, could you make an update of your work for the paper database? Because last update is last week. So Professor Liu let me to show show him a PowerPoint about our work. So I need to prepare. I need to show him your work. Uh,
Okay.
Maybe you can just make us update your work in some PowerPoint slides.
I think we can show Professor Liu our group presentations, what we present bi-weekly on each Wednesday.
Yes. I'm plan to show them that PowerPoint, but I will make some changes
Yeah.
tomorrow.
That is up to
For
you. That is fine. Yeah.
so
That is
so
okay.
so so need some update information.
For the updated information, I you can just raise those two fundamental questions like what I have mentioned right now, and what I'm going to mention in Slack. I think you can just put them directly into the presentation. That would be better. And also, based on the update, we can ask him about the effective data filtering, or maybe the things like the errors associated with our data filterings. We can also ask him.
We can discuss with him, but I think this time Professor Liu will just pay more attention to the scientific question of our work.
Questions.
Yeah,
I just mentioned, I think, one or two questions in Slack to you, I think.
we can discuss it with him. Uh,
Hmm. Fine.
uh, because the last time I talked with him about the scientific questions, and
Hmm.
he said that maybe we need more talk about it for the scientific
Naturally.
question, because uh, um, from our work now is not towards for a scientific question. It's almost
Yeah.
to check the data and for because the data is huge, so our whole work now is to see the data and another work is to make the data wash away. So
Exactly. Yeah.
so
Okay,
if
I will send the questions. Okay, then I will send the questions by tonight by using Slack, and you can have your own scientific questions. And I think it's better if anyone has any question, he or she can just put it to you, and you can decide based upon which whether it is scientific or not, and then you can just put it to Professor Liu. That would be better, most efficiency, I think.
Hello, I have one question.
okay.
The Chinese paper, how can I find DOI of the Chinese paper?
For Chinese papers, the deal I I think some Chinese people some Chinese papers do not have the DOI, but for some Chinese people, I didn't say they have the DOI, so maybe you can make them in different Excel files and mm, and we say if they have other ways to identify the Chinese papers with something like the DOI.
Okay.
Okay. So I guess it's all of our today's meeting.
Yeah, fine. Fair enough.
Thank you, Patricia. Maybe shall we turn off our videos to say hello to each other?
I will try my best to show myself, but I am not sure whether I can do this. Let's see. Okay.
Yes,
Okay, I am visible. Very nice.
yes,
I am
I can
visible.
see you. Hello,
Hello. Yeah.
hello. So good
Hello.
night.
Good night. Have a good night, and we will discuss it tomorrow. The rest part. Okay.
Yeah.
Okay. Fine. Good night.
Thank you for your explanation. Bye.
Bye.